guess today is that you're gonna see a different view of how to make a search strategy to afford scientific literature, to identify specific research topics for your research, for your thesis, for example. And we have this problem now is not to get the information, but actually to find the proper information that we need. So Urlich Web sets that or calculates that there are um, this amount of academic titles. Yes, almost 2000 k journals, academic journals. From there, from that number, we see that 96k are peer reviewed. That is really important regarding the science. We know that this is the foundations of how science works, the peer review. So you have your ideas, put it on a manuscript, and someone that is someone that are experts um, make a proofreading of this, and this is the peer review, and this is how the science grows day by day. And from this number of journals, 27k are indexed in Scopus. This is almost the 20% of the peer review literature. But you're going to see that we in Scopus have more journals indexed. I'm going to tell you this further. Scopus is a database for references. It's not a database for full text. So you're not gonna find, as you know, the full text, the PDFs on Scopus. You're going to find the link to go to the PDFs, to the actual documents. Scopus is a reference database. So we collect the metadata of the publications, and with that, we actually create 4 databases. One for authors, one for journals, one for documents, and one for organizations, okay? We have almost 99 millions of records. So we are near in the few days, we're going to have the 100 million records on Scopus indexed, and you can see that there that 99 million of documents came from 20 million of author profiles of authors that are part of 94,000 affiliations institutions. Okay. We collect information for 7,000 publishers. Scopus Elsevier journals are only like the 9 or 10% of the all documents indexed in Scopus, and almost the half of the documents came from institutional organizations like universities or research institutes. From commercial publishers, it's only the half or almost the half of the publications of the documents indexed in the Scopus, okay? Just to remember, Scopus collects information from all the areas, the knowledge areas, physical sciences, health sciences, social sciences, as you can see here, is the biggest one, and life sciences, that is my background, is the lowest number of journals, but it's quite good. We have almost 8,000 open access journals. We collect information from journals, from conferences, from books, and we are already collecting documents from preprints. Okay, saying that, Scopus' vision is to help the researchers to give you information that allows you to make high-value decisions with some background, truthful background on it. And this could be the main challenges of the research, and Scopus is helping us in the conducting research, uncovering the most relevant research. And that is what we are going to talk today about the search strategies, okay? So we are going to make a travel about from ideas, concepts, and how these could become, sorry, is that an open mic over there? I can see. So go to the actually how to convert these ideas into a proper research search, okay? And let's go for it. Okay, what's happening? So the ideas. When we think in something in our brain, there's not just one place where the thinking starts. There are several spots on our brain that enlight when we think in something. So each idea is associated with several places on our brains. The main example here is that we link different types of things. For example, properties, categories, causes. And if I said lemon, maybe you can think on green or on yellow, depending on the cultural known of what is a lemon. If I said banana, you may think on fruit in some places. If I said virus, you must think on disease. So these are the kind of things that I am talking about when you think about a concept. Your brain make the link to other categories, properties, causes, and such. So this is the way we must start to think in our research issues. The activation of one idea causes other to be activated, like when you throw the stone on a pond. So the ripples propagates in many directions. So when an idea has been activated, doesn't activate another idea, activate many ideas. And how, the question is how we can map these associations, okay? And we have a tool that is the concept maps. So the concept maps are diagrams that represent ideas as node link assembles, okay? In the concept maps, we structure a diagram in which the nodes are used to represent concepts. So the nodes here, pollution, land pollution, basic pollution, recycling, are the nodes, and the links connect the nodes represent the relationship between the nodes, between the concepts. So what is my propose here? My propose here is that you can start your research using concept maps. You just throw out the ideas that you are thinking on. It doesn't matter the order. Just put it on a paper or put it on a solution like the one I'm going to show you. And then you start creating the links. You're going to see that you have to move some of these things and create some kind of neighbors. And these neighbors should be the concepts that you must work with. This tool that I propose is Visual Understanding Environment. Is open source software. If you want to do it, or if you want to make this in another kind of software or just in paper, you can do it. But we can use this as the first insight to create your research searches. And now think that we need to understand and know which is the landscape, the knowledge landscape I'm working on. Maybe something I know a little, maybe something I didn't know at all. So we need to start to create extensive and intensive searches. And how does it work? Let's think the extensive searches. So this landscape is your knowledge landscape, and maybe is not that known for you. Maybe something new. So you need to start throwing drones, like in this picture, and these drones are going to take aerial photographs and have some sensors that they're going to give you the general view of what is happening here in the cloudy mountains. You can see anything. You need to send some explorers to find the information that you want. And this is the extensive search. So the first thing that you have to have is the complete landscape of the knowledge domain that you want to work with. Okay? And what does it mean? Extensive search means big picture recognition, means identification of promising topics, means identification of similar concepts, mean discovery of unknown terms, and you use these kind of connectors or something or something or something to start create this big picture. What for? To understand, it's related to broad, to long range, similar things, ranks. So this is the kind of things that we want to have on an extensive search. But then you have to drill down to go to your specific needs. And this is the drill down part. So the cross section that we have here means that we need to find, sorry, there is some open mic here. I'm going to mute. Okay, so we have here a promising part of the landscape that I want to go down, to drill down, to find if this is the place where I'm going to find my gold, where I'm going to find my petroleum, the value of my search. Okay, and what does it means? This means an intensive search. This intensive search is to find the frontiers of knowledge. And how do you find these frontiers? Because you start seeing that there are lesser and lesser number of documents talking about the topic that you want to know. So when you, or maybe there are not, there are no documents at all. These are the frontiers of the knowledge. There's not anymore. And these is the things that you want to find if you want to create new knowledge. So if you want to find your specific research area for your PhD that needs to be new, novel, you need to find frontiers of knowledge. So actually you want to not find anything, but you need to have a method to see that you are sure that there is nothing on this topic to work on it. So these are words like concentrated, particular, fully, local, and you use this kind of Boolean operators like and to make the intersections on that. Saying that, maybe you just find some little things or nothing at all, and you need to expand your search again. Okay, and what does it mean with the expansion? You need to grow again your search, move it a little bit further, and start growing again, using references, for example, similarity of documents, how to multiply the searches that you already have with related documents, with cited by, with semantic analysis, and other tools that we have already on this. So if you doesn't find anything, you're going to be on a local minimum, let's say. So you need to understand or to find that if in the neighborhood you are going to find something or not. And for that, you need to make an expansion again. Let's make an analogy. This could be a strategy called bow tie. Let's call it bow tie because it looks like a bow tie for me, at least. So in this axis, we have the number of results of documents. And of course, you're going to spend a lot of time making this search. So at first sight, you need to make an extensive search, okay? So the landscape, and you're going to have a big amount of documents. Then you have to start filter that initial search going for your topics of interest. And then you're going to find a few kind of documents. Maybe some of them are not well related, but you need to start moving in an expansion phase and grow the search again. And then you can do it several times until you find the proper set of documents that you want to. Okay. So how can you see this? Because you start with a big amount. Actually, when did you know that your extensive search is finished? When you put more words on your search and there's not a increase of the results of the documents. Okay, so when you find that these start to not to grow but to stabilize it, you know that your extensive search is finished. And then you start reducing until you find the set of documents of the topic that you want. Maybe you need to make some expansion to find things that are relative to your search, but not exactly the same, to see all the scopes and then do it again. But the number of documents will decrease each time that you make the intensive and extensive search, or the expansive and intensive search again. And this will take you some time. Okay, for PhD without these tools, this will, before Scopus and all that things, took months to make this work. Okay, now what with the tools that we have, for example, with the Scopus, you can have this in 40, 80, 120 hours maybe for a PhD research. And now we are having better tools that maybe could short these times. And we see that at the end of the session today. So let's see which tools we have on Scopus to make this. And you're going to have the search operators. Okay, you if you point or take a picture and a screenshot of the screen right now, you're going to have this QR code that will leave you to also this URL that is the Scopus help page talking about the search operators. You must know which are the Boolean operators. I'm just going to make a quick view on it. It became from the George Boole theory that his document is named An Investigation of the Laws of Thought. This is amazing for me because the laws of thought in 1815, okay, and it based the mathematical theories of logic and probabilities, and we use right now that theory as a tool. I'm going to represent in some way how does it works with in searches, okay? So, for example, I'm going to look for cancer diagnostics and then make a search, and I have this set of documents, a number of documents, and then I make a search of about machine learning, you know, and this give me this set of documents. Okay, now I want to know how machine learning is helping on cancer diagnosis. So I can make a search of cancer diagnosis and machine learning plus machine learning, and I'm going to have a bigger set that corresponds to both of the results of the separated queries. So this increases the total number of items. How? If I use the OR operator, okay? But if I use the AND operator, this is going to give me the documents that talks simultaneously on cancer diagnosis and machine learning, as you know. So I'm going to decrease the number of documents using AND. And let's see, this is really important because you must set, as a strategy, you must set which are the domains that you're going to search on, and then start connecting them with ANDs. Okay? So this is the way you start creating your advanced queries. But these are not all the only operators that you can work with. We have also proximity operators in Scopus. So the double quotation marks. This is an approximate phrase, okay? Not as in Google. Remember, in Google, the double quotation marks are exact phrases. In Scopus are the approximate phrase. We search not exactly for the string of characters. So you can see the differences. For example, if you search for heart attack, you're going to have this number of results, and with these quotation marks, you're going to have 22 results. Why? Because if you doesn't put the quotation marks, they're going to look for heart and for attack, even if not for the concept of heart attack, okay? We have also curly brackets. These curly brackets are for the exact phrase. So it searches exactly what you have here in characters. So you need to know that. The asterisk, the star, replaces any number of characters and is used as a levanticizer to include all inflected forms such that, if, for example, if you write multiple and a star, is equivalent to search for multiple, multiply, multiplyable, multiplying, or whatever kind of variants do you have. And the interrogation replace a single character. So, for example, if you search for HE and interrogation is equivalent to looking for hen or her, for example. There's another kind of proximity operators that for me is like vacuum cleaners, because these are amazing to find things that I'm not really know how they are related. So there's an operator that is this one, W/N, that indicates the distance between words, but not in the order, in the strict order. For example, if I search for journal, W/2 publishing, journal can be found in 2 words away from the word publishing, okay? And if I use pre/n, this appears in the specific word order. So behavioral pre/3 disturbances, where behavior precedes disturbances by 3 words, okay? So if you doesn't know which are the specific relation between 2 terms, you can try to find in the same sentence using 15 as the number. And if you want to search in the same paragraph and see that you can search on paragraphs using, for example, 50 words. So this is an amazing way to find information that I know that they are related, but I don't know exactly how. There are some rules on it. These proximity operators can only be used in terms of phrases, not with expression that contains and, or, and not. Okay, so this is invalid. Prefix chip and channel and fish. This is not going to work. You need to use it, like for example, in bay prefix chip, and you can use a star as well. Okay. There are also other examples. You can include multiple different operators and different values of n in the same search, but not with the same expression. So, for example, you use the interrogation here with chip and chip P0 channel, for example. And there's an order of precedence that you must know. The first one to solve is going to be the ORs. The second ones are going to be the WN. Third, you're going to the Scopus gonna solve ands, and last one gonna be and nots. Okay, so you need to know that because the results are different if you put it in brackets in a way that you were not thinking really well. There's also another kind of codes that we can use in Scopus. These are used in advanced searches for a terminal specific field. You can see all the list on this URL. So if you want to check by your own, you can have that URL. And which kind of field codes I'm talking about? There are some categories like textual content, affiliations, authors, biological entities, chemical entities, conference, etc. You can read it. And these are the field codes. For example, for textual content, if you use apps, you're telling that only search on abstracts. All are gonna search on all the fields. Title, gonna search on title. If you use title abstract, it's gonna search on title and abstracts and so on. Okay. And for example, for authors, you can see all these fields that you can find: ORCID, the author ID, the last name, the first name, etc. Conferences, you can search for sequence search numbers for biological entities, DNA chains, for example. You can ask about the document, doc type, if you want to search for example, chapters, book chapters, or just conference papers. You can search and filter by that. Also, if you want to find who is funding some kind of research, you can make that query. You can use keywords as key manufacturer, trade name. You are seeing it, and I know that you get it. So this can help you, depending on your interests on your topics, to make a more accurate advanced search. And there is also a categorization of the knowledge on Scopus that is called all science journal classification. Okay, and this is a taxonomy of knowledge. All science journal classification is a classification that we give to the journals, not to the documents, but to the journals. And a journal could be in one or more than one category on all science journal classification. If you want to understand and how this is configured, you can click. You can take the URL from this QR code, and you are going to go to the current classification if you want to see it. But let's say that we have all the 4 areas that I told before: the medical sciences, physical science, life sciences, and social sciences, divided in 27 thematic areas, and also we have a multidisciplinary research area that is the 1000. Okay, and each of these thematic areas are subclassified in many classes. So life sciences are classified in 5 classes. Each of the classes has a number of 4 digits, or you have a textual representation of each of it. So if you look for sub J area, medi or nurse or beta or dent or heal or mult, you're gonna search for each or for all of these sub areas: medicine, nursing, veterinary, dentistry, health professions. Okay, so life sciences are broken into 5 classes. This is not life sciences. This is medical sciences. Sorry, this is not life sciences. It's medical sciences. Sorry for that. Life sciences are this one. Life sciences broke also on 5 classes: agricultural, biochemistry, biology, neurosciences, pharmacology, and then you have the text representation of each of them. Or you can have physical sciences that broke on 10 classes, is the one with the most number of classes, that came from chemical to computer science, mathematics, physics. So physical sciences are broken on 10 classes, and social sciences on 6 classes: art and humanities, business, decision, economics, physiology, social sciences, and so on. And each of these classes are broken into subclasses. So we have 336 thematic sub-areas to classify the content. And the code to use this is sub-j-main. And then you put the number of the code, because this classes doesn't have a text representation. The sub areas don't have a text representation. You must use the number, okay? And you can consult the area code downloading this Excel file. You can have here the URL, or you can click. You can get the URL pointing to this QR code. Okay, an example is, for example, multidisciplinary, as I told, is a separate one that is 1000, and then agricultural and biological sciences breaks into these sub-areas: general agricultural, agronomy, ecology, forestry, and the ones that you see here. Okay, and each of the areas breaks into several sub areas. Okay, then you can search on that on the advanced search mode on Scopus. Okay, you can have help, for example, in the subject areas. You're going to see health sciences, life sciences, physical sciences, and social sciences, and you can add one or many of the sub areas. Okay, and let's go for an example. Let's go for an example. First of all, I want to see if there's some questions. At this point, let me check. Yes, it seems. Okay. No, I see no questions at all. We should put some link on the chat.
We just Carlos, sorry to interrupt you, but I'll just share something with them. Donc, tous les gens, pour obtenir l'attestation, vous pouvez cliquer sur le lien ce que j'ai déjà partagé avec vous dans la boîte de chat ou dans la boîte de Q&A. Et aussi, j'ai partagé le code d'atelier pour obtenir l'attestation. Donc, merci à tous et je vais repartager le lien autrefois pour tous les gens peuvent obtenir son certificat. Merci. So you can go ahead, Carlos. Thank you.
Oh, well, okay. So let's see an example. I have this idea: the commercial exploitation of biodiversity products. Okay, because I am in Latin America, avocado is one of the products that I want to work with. Okay, so let's start working with this concept map. So this is a toy, no? This is a toy example. So this is just to show you how could this work. So my first concept is avocado, and I want to know about harvesting, about cosmetics use, for example, or food technologies. And then when I think about food technologies, I see that could be extraction methods, essential oils. Maybe this could be also with cosmetics. I don't know. Maybe this should be in this side. Okay, harvest and post harvesting, the names of the fruit, the family, the taxonomic family is Laurasia. The scientific name is Persea americana, and also I have the name in Spanish that is aguacate. Okay, so how I take these concepts and make an advanced query? How? Okay, we have to construct a search equation, and we made this file. We make this Excel file that you can download right now. That is like a bicycle with training wheels for the ones that are not experts yet on creating advanced queries. And this is a tool that we develop for you. You can download it and share it with everyone you want. Here is the URL, and here is the QR code to download it. You're going to jump into a page, and you can download the Excel file. And you're going to see this, let's say, training wheels cycle for creation of search strategies. This is just to make anyone to understand how does it works, and then you can, as in the bicycle, you can take out the wheels and do it by yourself in a better way. How does it works? Okay, you have to put on these boxes the concepts that you want to work with, the domains, the knowledge domains that we work to. So one domain is the name of the fruit, Persea americana, and see that I am using the quotes, the quotations right now. Food tech, that is food technology or whatever. So I use food tech, the asterisk, and also put it on quotations. Cosmetics, and use the star, and harvest. So I am looking for 4 domains, different domains, okay? And then when I put a domain, a word, a sentence, a word, whatever put on these cells, it's going to create these columns with the name of the domain, okay? And then what I have to do is to find synonyms of this word, okay? Synonyms is not just the semantic synonym, it's things that are related of, for example, classifications, categories, things that I have the intuition that are related on that concept regarding the topic I want to search. So for example, for Persea americana, I use avocado, I use palta, I use laurasia. For food tech, I use food science, food preservation, food preserve, actually, because I use the star. For cosmetics, makeup, hair core, hair care, care and skin, cosmetic compositions, toilet preparation, post-harvest agriculture, okay? And what the tool makes for us is to start creating this query. And if you see carefully, what you are going to see is that all these terms are going to be linked with ORs. And between the domains, and put it on brackets, okay? And link the domains with ANDs. So you're going to have a super big query with all the domains on it. And this could be your assistant research advanced query for the topic that you want to work with. Of course, this is a toy example. For a proper research, the number of terms for a PhD understanding could be 200, 250 or something terms. Okay, so this is quite low number of terms that you must increase with the things that you read. But let's talk about the construction of the search query. You have to check where are the brackets, where are the ands, and where are the ors, as I told you. And then, for example, I add sub J mains with some of the areas, of the knowledge areas that I want to collect the information on. So I am restricting, I'm making a restriction for some domains. And these domains are 1500, 1501, 1502, and you can see here which are the domains I take. General chemical, chemical engineering, bioengineering, catalysis, colloids, whatever. So I am making the search just pruning it with some knowledge domains. And then when I made that, I have 138 documents. And this will be my search query for this domain. Okay. You must also be careful with the syntax of the query that you made, because depending on the syntax, you're going to have different amount of documents. So for example, this one, Persia Americana, avocado, and food tech, whatever, 22 documents. If I use Persia Americana or avocado and Persia Americana, I put it on quotation marks, food tech with this advanced characters query, for example, care skin. You see the differences I am telling you about. This has a double bracket, okay, because there must be one domain here, cosmetic and toilet preparations, and then harvest. But I put both of them into an and. Or you can make this aggregation, different aggregation of the same terms. Okay, and then you're going to have different results. These are the things that you must check. But in Scopus is really easy to understand how this is working out. So when you go to Scopus, you go to the search model, then you check in the advanced query, and you can paste your query, and there you're going to have the number of documents, okay? If you log in with your credentials into Scopus, then you can save your search. And this is really important if you are working on your thesis. Why? Because then you can put an alert. And then when a new document comes into these results, you're going to be alerted on it. So you will be updated on the domain that you create regarding your research topic. So this is a really important tool. And I just emphasize, I call this the magic button. This is where the magic came from, okay? Because now I have almost 1,500 documents. It's impossible that I read all of that. Even if I have to read only the abstracts, it's going to take me ages. So I have this magic button that makes some of the bibliometric analysis for me. For example, if I click on it and see this is the query I was using for, these are the number of documents I have as a result, and it told me that the search starts on 1985 till 2025, okay? And I can see the authors, which are the authors, the most prolific authors for this topic I model with this query. So I'm going to have the first one as Santos NC, then Sang, then Aguilar, and so on. And I'm going to have the chart that shows me that the expert on this topic has only 9 papers, okay? So this gives me a really perspective, a good perspective of which are the ones more prolific authors and how much papers they have on this topic, okay? If you want to see the papers, you just have to click on the number. And if you want to see the profile of the author, you click on the name. So if you want to check the papers, click on the number of documents, and you want to see the person, check on the name, okay? But also, okay, this is the profile. So you can see more information of the guy. You know that this guy is working on Brazil. If it has the ORCID, you can check on it, but this is the profile name in the Scopus, and you are seeing the publications and citation of this author, okay? Then you're gonna see more information related to the profile. If you want to be an advisor for you, you can check these names, or if you want to need a board member for your research, you can check on these names also as well. You can see documents by year and see how this is growing. And this is important. Why? Because when you see an elbow, like I see an elbow here in these years, you see that there is a trend and then start changing, but they change really on this. So the documents from this year, that is 12, 20, maybe 15, it starts to grow this topic that you model with this query, okay? So you are seeing how is the dynamics of this topic in the Word using Scopus as your field for this search. Also, you can see where are the people publishing on this topic and how this came on the years. So you're going to see that the most number of documents on the topic are on this journal, but you can also see how this works regarding the time. If you want to read more or publish, you know now where are the first places to publish on this topic. Also, you can see the institutions that are related with the publications. So if you want to make an internship or make a or see if you have some contacts, or the university have some contact with some institutions, you can see which are the institutions with the most publications, and also use that for your research. You can also check on the countries that are working on these topics. Then you can see that Australia, for example, is the most prolific one, then the States, Brazil, Vietnam, France, etc., etc., etc. If you want to search for example, a place to make your PhD, could help. And then the subject areas. So most of the research, and also see that I made a restriction on chemistry things, chemical engineer, agricultural, chemistry, engineering, and so on. So you can see specifically which papers are related to these areas, and you can make a further deeper search on it. These document types told you how this research is making. Most of the publications are papers, and the next one are conferences. So if you check on the conferences, you must see at which conferences you must go, because are the places where the people are talking about these issues, okay? And in which topic specifically. Then, if you need money to fund your research, you can see which are the main institutions, the main funded institutions that gives money to sponsor this research. So these are collected from the acknowledgement section of the papers, and you're gonna see that the most funded research came from the National Natural Science Foundation of China, and then from Brasil, Coordenação de Aperfeiçoamento do Pessoal de Nível Superior, and so on, okay? So you're gonna have a research overview of the topic that you want to work with many of the analysis that you already have in Scopus, helping you to afford your research proposal. But that's not the all the things that you can have. Maybe you want to make a deeper analysis, okay? So you can export all of the documents that you look for with your query to a CSV file, a RIS file, a BibTeX file, a plain text, or also export it to reference managers, or if your institution have Cybal, to Cybal. That is an analytic solution from Elsevier as well. And let's talk about these files, because when you export to these files, you can actually configure the fields that you want to export. Okay, so you have different fields, and you can check the ones, and you can also record if this is going to be the analysis you're going to make each of the times. You can record it, and the second time you doesn't need to start checking one by one. You just use your let's say template of selections, okay? And then you're going to have, I'm going to export this into a CSV file. So then I have these results of all the fields I check, okay? And for the number of documents I make my query. And why I want to make these kind of files? Because we have amazing tools, different from Scopus, that help us on making beautiful and better and further, deeper bibliometric and scientometric research. So maybe your first paper could be a bibliometric study of the state of the art on your research field. So you can use Boss Viewer, that is open source software also, and you can create these beautiful landscapes of co-authoring, or you can use Bibliometrics, that is based on R. It's also open source, and you can make this, for example, analysis using principal coordinate analysis that told you which are the domains, which are the words or topics on each of the domains, and how this works on the time, and make further analysis on this. For Boss Viewer, you need to create a RIS file, and then you upload it, and you're going to have your results. For example, here, for database files, Scopus, dimensions, and whatever. And then you're going to have your research. And for example, you can have this kind of results. Or from Bibliometrics, you download the bib file, and then you can make these beautiful charts with it that helps you on how to do it. We have a couple of minutes. I want to know if we have some questions. If not, I could spend a couple of minutes talking about a friend that we can have for making this in the new age area. Okay, let's see. I see no questions at all. Bishoy, do you have some ones? So
Yeah, let me check here. Yeah, how can I download the certificate? Like I shared with you, all of you, the links. I will share it once again. Can we get this presentation? I think yes, Carlos, if it's not a problem. Yeah. Yeah, there's a question. What means in the search? What means the store in the search?
As I told, it's like a lemmantizer. So from the start, you can you use the root of the word, and then the star means that it's going to take all the derivations of that word and put it into the search. So you don't have to write 10 words that with a different ending. Like, for example, as I told before, there's you can review it on the video, but you don't have to make researcher, researching. You don't have to make all that words. You just put research and the star, and it will take all the declinations of the word.
So, are these analyses similar to those which can be done on Insights?
I don't know
Scopus
Insight, sorry.
Yeah, okay. Uh, are these graphs usually used for bibliometric analysis, or is it
Yes,
recommended to produce our own?
both of them. If you want to spend a lot of time doing it, just do it.
Yeah.
If you want to check to take one of these ones, you can take it.
Okay, one more question. How can we build an advanced query to identify journals recently indexed in a Scopus in a specific field?
Uh, you make the search. You have to model your field with an advanced query, and as I told you, I showed you just a couple of slides before. You are going to have the journals. Oh, you can see it here. These are the ones, and you have for all the time, so you can check the last years if you want.
Okay. Yeah, I think that's it for the questions. So if you'd like to share.
I don't know, Bishoy. I just want to. This is the end, okay? This is the end of the session. But if
Okay.
you want to see, how we can call a friend to make knowledge discovery easy, I can spend a little minutes talking about Scopus AI and how this
Please.
could help you.
Oh, yes, yes, yes. They know already
So,
about Scopus AI, but yeah, but it's good to give some teasers, right?
okay, yes. For example, Scopus AI is an additional subscription to Scopus, and if your institution subscribe, you're gonna see it at the end of the menu, okay? As a Scopus AI, and it will tell you that it's a new thing, and then you don't need to make an advanced query. You just put the thing that you want to ask in natural language, okay? So I want to learn about the use of CBD in pain treatment, for example, and then I make the search. And what I'm going to have? I'm going to have a copilot here that is helping me in many issues. Copilot give me transparency of the knowledge discovery query. Why? Because this creates a phrase in natural language, and also it creates a seminal, an initial advanced query, as you can see here. Okay, so I can copy and paste this one and use it in scopus.com in the document search. So because Copilot did this thing, I reduce the risk of bias prompting. Also, I can do it in any language, and it's going to translate it to English. And as I told you, it's going to give me an initial advanced query, okay? So I can use this as a seed, not just to look in Scopus, but also if I use ChatGPT or something, I can put that advanced query and say, okay, improve this with more synonyms, for example. And for Scopus search, advanced search, and maybe these other tools can help you in increase the number of terms on your copy. Then we're going to have a summary of the topic, okay, with references, actual references, not like the ones that you have on ChatGPT that are fabricated, almost fabricated references. You're not going to have truly references. In Scopus AI, there's not a chance that you have a fake reference because the search is just do it in Scopus, not on internet, or not just generated by the AI. These are actually true references of documents that are indexed in Scopus. So this gives you the confidence that this is truly information. And the language for the summary is a language that anyone can understand, reducing the silos fractioning of the knowledge. Okay. Then you're going to have foundational documents that are the documents that all of these references cite in common. And these are the ones with the highest numbers of citations, for example. Also, you're going to have an expanded summary that gives you another dimensions or views of the problem that you are looking for. Maybe there are things that are interesting for you. And this gives you a concept map, an initial concept map that you must use if you want to increase your knowledge of the area and understand how this works. Also, this gives you a list of experts and tell you why this guy could be an expert on the topic that you are looking for. Okay. Finally, this is the most addictive thing on the world, the go deeper. So it's going to suggest you 3 questions that you can look further. So you can go deep and deep and deep and deep and deep and spend all your life making queries here. So this is the way that Scopus AI could help you on your research, also making it easier for you. Here are some concept map literature if you want to go deep on this concept. And that's all, Bishoy.
Yeah, amazing, Carlos. Thank you for your presentation. Very enriching, and hopefully it opened the doors for a different perspective about how can we use Scopus in a different way. Thank you very much once again. Donc, merci tout le monde pour la participation dans la session d'aujourd'hui. Donc, si tu veux ajouter quelque chose, Karima. Voilà, donc je pense que Karima n'a rien pour partager. Donc, merci à tous pour votre participation et au revoir.